Our given quantity is 4.29 moles of silver. Remember that silver is one of our elements whose symbol matches their name poorly, so it's worth working to recognize silver as Ag. We are asked to move from moles of silver to grams of silver. Reviewing these units, it looks like we'll need silver's molar mass to complete this, as molar mass is a definition of the amount of mass present in a single mole of the compound. Finding Ag on the periodic table, you'll see that the molar mass is 107.87 grams per mole. Multiply the moles given by the molar mass we just located, and we'll have 462.76 or 463 moles of silver. Go us! If you take a minute, you can do a quick rough double check of your calculated value. If I only had 1 mole of silver, then it would have a mass of about 108 grams. But I have over 4 moles of silver, so my sample should have a mass of well over 400 grams. The value we calculated fits that bill. It's actually very important that you double check your work to ensure that any values you've calculated make numerical sense. Our calculations are all driven by theory, and there will definitely be questions that focus more on the theory than the series of calculations come quiz time. Again, start with your given quantity, which is 1.15 grams of carbon. Here we need to move from grams of carbon to moles of carbon, and again this looks like we'll need the molar mass from the periodic table. For carbon, that's 12.01 grams per mole. Divide the mass by the molar mass, and you'll be left with the moles of carbon present in your sample. Again, take a minute to think about whether your answer makes sense. 1 mole of carbon would have a mass of 12.01 grams, and we only have 1.15 grams of carbon here. So we should end up with a value much less than 1.